Welcome to Data Science with EJD. Starting from this video, I'll be talking about reinforcement learning as promised. And in here, we'll be talking about introduction to reinforcement learning. In particular, I want to understand reinforcement learning and its place in machine learning. So if you remember, we said machine learning, is that concept where machines learn from data. Of course, that is with the use of various models. And machine learning is subdivided into three different areas. We have supervised, unsupervised, and now reinforcement learning. So we've taken different algorithms under supervised learning, unsupervised learning. So we are going for reinforcement learning starting from this video. All right. So the outline will be looking at what learning is, reinforcement learning versus other machine learning paradigms like supervised and unsupervised learning, key terms in reinforcement learning, and some real-world applications of reinforcement learning. And then we have a conclusion. Now, the question is, what is reinforcement learning? Of course, by way of definition, reinforcement learning, or RL for short, is a type of machine learning where there's an agent that learns to make decisions by interacting with an environment to maximize a cumulative reward. A very good example will be in a gaming system, right? Like I remember one of the most popular games we play is something like the snakes game, so to speak. So the snakes is expected to eat some food. So as it eats that food, it gets longer. That is a kind of reward. So if it doesn't eat the food, it remains the same. Then you also want to ensure that the snake does not hit a wall. So when it hits a wall, you lose some point, like maybe the game is over or something like that. So in that whole process, you see that when the snake eats the food, there's a reward in place. When the snake hits a wall, or if it hits itself, sometimes the snake becomes so long it hits itself, then the game is over. So that's some kind. So you have a kind of reward system in that situation. So that's a very basic example I can give about reinforcement learning, which is a type of machine learning where an agent learns to make decisions. So probably in the case of that game, the agent would be that person who is playing the game, right? Learns to make decisions by interacting with an environment. The environment is that gaming environment with the rules and regulation. So, and you're maximizing the cumulative reward. You want to eat all the food and make sure that the snake does not hit a wall, or it does not hit its own tail or something like that, so you can get the best reward possible. And the reward in that case will be winning that game and maybe going to another level. So, reinforcement learning is inspired by behavioral psychology, learning through trial and error. It's just like you have a child. So, when they do well in school, maybe you get them a bicycle. When they don't do well, maybe they don't get to see their best shows or something like that. So, you have that reward and punishment system going on there. And the reason why you're doing that is you want to reinforce the right ideas in these children. So, reinforcement learning comes from psychology. So the key idea is that the agent learns optimal behavior through feedback or rewards rather than explicit instructions. So instead of giving instructions, you just as the process goes on, you can say, "Oh, this is good. You get an extra. You get $5, or you get 1,000. Whatever you want to give, or like you get 10,000 naira for each of these things you do, something like that." All right. So the core process is that you have the agent observe the current state of the environment. The agent takes an action. So using the snake game as an example, agents observe the current state of the environment. So maybe the current state is that the snake is far away from where the food is. You want to see where the food is and get to move your snake there. So agent takes an action. You move your snake towards that food. Then next, the environment provides a reward and transitions to a new state. So when you eat that food, when you successfully eat the food, the reward is that the snake grows longer and you win some extra points. Then, so once as the state grows longer, you see another food appearing somewhere. So that's a new state now. And then you go for the food and it keeps on like that. So the agent updates his strategy based on the reward. So you keep eating the food until you win the game. All right. So to visualize this now, this is from Wikipedia. Just like we said, there's an environment, like I've given the example of a gaming environment, and there's an agent. Of course, the agent could be the player in this case. So you as the player, you take an action in that gaming environment, and like the snake eats food, and if that happens, then there's a reward, there's a reward. So you get a reward, and then the state is updated, and then you continue like that until you get everything you need to get from the system. So the RL loop is such that there's a state, there's an action, there's a reward, and then the state is updated. So the goal is to learn a policy which is pi of A given S that maps states to actions, right? So action given a particular state, to so that this function maps states to actions to maximize long-term rewards. So looking at reinforcement learning versus supervised and unsupervised learning. So the goal, for instance, for supervised learning, the goal is to predict labels for data using labeled examples. So when we talk about labels, we're talking about features and targets. The features are the inputs, while the targets are the outputs, right? Usually you have one target and several features. So the goal in that case is to want to predict labels for data using labeled examples. For unsupervised learning, you want to find patterns or structure in unlabeled data. Unlabeled data is a situation where you have just features and no target. So you have those features and you just want to discover patterns from them. You want to see which ones can be grouped together and all that. And then when you talk about reinforcement learning, you have to learn, in this case, you are learning optimal actions to maximize rewards. The kind of data, like we know, supervised learning requires labeled data where you have input and output pairs, where you have, you have features and targets. All right. So the target is determined by the features. Then for supervised learning, you have one labeled data set, which is just only inputs, you know. So you have just the features, like I said already. For reinforcement learning, the data is you have interaction. The data you get is based on the interaction with the environment. So you have states, actions, and rewards. Those are the data. So it's just like the snake game situation. You have the snake eating food and getting bigger, and it keeps going as much long as it eats the food, it gets rewarded with longer lengths. And then by the time it eats all the possible food at a particular stage, the game is won, right? So for the feedback, right, the supervised learning feedback is explicit labels or correct answers. So it's more like you have so you're trying to determine a person's growth, based on genetics, based on environment, based on nutrition and all that. So by the time you use you have a training data set, and you have trained your model on that data set, so you can now say, okay, for a growth of this particular factor, what do we expect, or given these factors, what kind of growth do we expect? So you can actually predict. For unsupervised learning, there's no explicit feedback. You're just it's going to see the patterns. For reinforcement learning, the feedback is delayed rewards based on actions, right? That'll be the feedback. For instance, if the snake fails to eat the food, and so you just keep moving the snake around, and then if it hits a barrier like the wall or its own tail, then there's so there's no reward. In fact, maybe there's a punishment for that, like you lose the game. So examples for supervised learning include image classification and regression. All right. And then for unsupervised learning, we have clustering, dimensionality reduction, and even association rule learning. Like when you can like talking about the market baskets analysis, or things like a priori algorithm and all that. So for reinforcement learning, typical examples would be in game playing and robotics, right? Um, all that. So reinforcement learning is unique. It doesn't require direct supervision, and it learns through trial and error. So okay, of course, here we're talking about differences between supervised and unsupervised learning. So key differences in practice now. For supervised learning, you predict outputs for inputs, e.g., classify an image as cat or dog. So you feed your system with some pictures, and you want them to be classified as cat or dog, right? Based on the picture. Then for unsupervised learning, you want to just group similar data points, e.g., customer segmentation. For reinforcement learning, you're optimizing sequential decisions, e.g., a robot navigating a maze, right? So why reinforcement learning is challenging? Number one, it is you can have sparse or delayed rewards. and then exploration versus exploitation trade-off, and then dynamic and uncertain environment. All right. Of course, the whole idea is about trial and error. That's one big challenge about reinforcement learning. So let's look at some key terms in reinforcement learning. First of all, you have the agent, you have the learner or decision maker, e.g., a robot, a game player. Just like I said before, if you're playing a snake game, you are the agent in that situation. The environment, everything the agent interacts with, e.g., a game board, physical world. So the snake game, of course, you have maybe like something that you hold, and then the whole environment, how the game interacts with the food, its wall, its own tail or something like that. Then you have the state also, which is a representation of the environment at a given time. The state may be that, oh, the snake has eaten one food and it has become a bit longer. That's the state at that time. And then by the time it eats the next food, it be the so you take that's an action. So an action is a decision made by the agent that affects the environment. So from a particular state where it has eaten one food, it eats the second food, it becomes longer based on the action of eating the next food. So it becomes longer. So the reward now is becoming longer for the snake. So that's the feedback signal indicating the quality of the action. Okay, well, we even use reward in the broad term here. So reward can either be positive or negative. So reward, I mean, the normal sense idea of reward is positive, right? But here we are using it in terms of both reward and punishment, right? So if the snake fails to eat the food, so the best situation up, the best situation apart from eating the food is moving the snake around and making sure it doesn't hit the wall. But of course, that doesn't get you anywhere, no progress, right? But but if you eat the food, you get positive reward, like you get higher points. But if you hit the wall, maybe you can lose a lifeline or something like that, or you can lose the game altogether. So reward is that kind of blanket thing. It can be positive, negative, or neutral. Okay, so then here we have a policy, right? Policy pi, that's a strategy that maps states to actions. So mapping state to action in the case of the snake game is like, so the state of the game at any point in time is the length of the snake. The action is eating the food. So the policy is eat the food, right? When you eat the food, you have fulfilled the policy of the game. And the value function, this estimates long-term rewards for states or state objection pairs. So, and the idea is the objective is to maximize cumulative reward, which can represent we can represent that as summation from t equals 0 to infinity of gamma raised power t r sub t, where gamma belongs to it includes 0, but it doesn't. It's from 0 to 1 with 1 excluded. So you have some value between 0 and 1. All right. So, but you want to get to as close as 1 as possible with the gamma. So gamma is the discount factor, right? So then we have RL terminology in action. So for instance, training a robot to pick up objects. So the agent here is the robot's arm, right? The environment is the workspace with objects. Like maybe we have a warehouse. You are designing a robot to lift cartons, to lift boxes in a place where things like that are sorted. So the state is position of the arm and object at every point in time. The action is whether to move arm left, right, up, down, or grasp, right? So the reward is plus 10 for picking up an object, minus 1 for each move, minus 5 for dropping, right? So the ultimate goal is to be able to pick up an object at the end of the day, right? So the robot learns a policy to efficiently pick up objects while minimizing penalties. Okay, real-world applications of reinforcement learning, gaming, I've said that from the beginning. So reinforcement learning agents mastering complex games like Go, that's like AlphaGo, StarCraft, and Dota 2. Then you have the robotics, you have the application in robotics, right? Training robots for tasks like walking, grasping, or autonomous navigation. Then you have autonomous vehicles for sure, for optimizing driving policies for safety and efficiency. So autonomous vehicles, they're expected to drive safely, right? They're expected to see cars ahead and wait a considerable distance so as not to hit them and things like that. So avoid barriers and know when to turn and things like that, the right angle to turn and all that. Then in healthcare also, you have personalizing treatment plans or optimizing drug dosages, using reinforcement learning. Then for finance, portfolio management and algorithmic trading, right? So a very good example is AlphaGo, like we said before already. AlphaGo was developed by DeepMind, which used reinforcement learning to defeat world champion Lee Sedol in Go. So combine reinforcement learning with deep learning to evaluate board states and optimize moves. Okay, more applications. We can have more applications in natural language processing, like dialogue systems and chatbots optimizing user interactions. I mean, technically, right? If even the idea of generative AI we can see it as some kind of reinforcement learning because the more data you feed an AI, the better it gets with decision making, right? And for each person, the kind of data you feed as you, of course, you have your own interface with every AI tool you use. So whatever you feed the AI will determine how, for instance, if you have used your maybe ChatGPT for some time, by the time you go back there and then you ask, what can you say about me? So it knows the kind of information you have fed it over the time. And so that's some kind of technically, maybe not reinforcement learning possible, but something close to that, right? But because you can even have dialogue with that, right? So dialogue systems and chatbots optimizing user interactions. That's the basic idea I'm trying to explain. Then resource management, optimizing energy consumption in smart grids or data centers can be some kind of reinforcement learning. And recommendation systems, personalizing content delivery to Netflix or YouTube. Of course, you discover that the kind of things you see on YouTube will determine the kind of things you get to see over time. Okay, so why reinforcement learning? Why do you need reinforcement learning for these tasks? Because it handles sequential decision making, it adapts to dynamic environment, and it optimizes for long-term outcomes. In summary, reinforcement learning is a unique machine learning paradigm where an agent learns through interaction with an environment to maximize rewards. So you have an agent, you have an environment, you have a policy, and you have rewards. So it differs from supervised learning for label data and unsupervised learning for pattern discovery. Learning it differs from these two, right? Due to its focus on sequential decision making and delayed feedback, right? Key terms, you need an agent, maybe the player of the game or the robot you are looking at. You need an environment. For in the case of a robot, the warehouse or even if it's a robot that cooks. So maybe the kitchen is the environment. The state is how close is it to the cutting board if it needs to cut something, right? Or how close is it to the stove or whatever it's required to do. And the reward is so doing the job right, you get a reward. Doing it wrong, you get a negative reward, like maybe you lose some points. Policy, that's what maps actions to state. Then you have the value function. So wide-ranging applications includes gaming, robotics, healthcare, finance, and more, right? So the next steps, we can explore real reinforcement learning algorithms, e.g., Q-learning, deep reinforcement learning, and we can experiment with reinforcement learning environment like OpenAI Gym. In fact, in the next video, I'll be doing something with OpenAI Gym. Let's look forward to that. So in all, you can subscribe to my YouTube channel. I already have a lot of things on data. I started with data analysis with Python, where we focused a lot on pandas. Of course, we started with the basics of Python, right? How to navigate Python codes and things like that, Jupyter Notebook environment and all that. So you want to click on this to subscribe to the channel like that. So yeah, so this is the channel. Now we have 1,000 subscribers. Thank you for those who have subscribed already. So of course we have to go on for the next goal of 100,000 subscribers. So let's go for it. Just go ahead and subscribe to the channel, right? So next you can also explore the playlist. I have several playlists. Just like I told you, I've been dealing with data for some weeks now. So okay, I mean my books, you can also see my books here. Then, of course, there is data science with EJD. That's the playlist I'm adding this to. And then you have SQL with Python, then data analysis with Python, ordinary differential equations, partial differential equations, so many numerical optimization techniques. So some of these things are even foundations to data and data science, right? Like calculus, game theory, graph and network theory, linear programming, statistics, probability, vectors, power series, all this in set theory, scientific computing, trigonometry, and all that. So, I mean, of course, it's more like there's something for everybody here. So, if you like to study the Bible, I have some Bible talks. I also have some interviews where I share all kinds of ideas on scholarships and everything, on jobs and things like that, personal development, complex analysis, complex numbers, and so on and so forth. So, you want to explore these these playlists, then of course you can become a member of my channel with different perks. Just click on join. Yeah, so you see, you have three levels now, and there are different perks attached to each level. So be sure to subscribe to the channel so you can be part of this movement. It's been such an exciting time, doing this from time to time. So subscribe, explore playlists, join if you as a member if you can, and of course, let's keep learning together. So this brings me to the end of this video. Let me know how helpful this is for you. And if there's something you'd like me to try out, feel free to let me know. In the next video, we'll be talking about MDP. You'll find out what MDP is. Just watch out for that. All right. So from there, be sure if you have not subscribed already, please go ahead and subscribe, and be sure to hit the notification bell so you can always get alerted each time a new video is released. Um, be sure to like and share also so that more people can have access to this great content I have here. My code sheets, my slides, data sets are all available. Just look at the description box on YouTube or Facebook, and you can get them on Google Drive. So download everything. In fact, I always advise have them downloaded, and then you can follow step by step, because the best way to code is to code. Don't watch video and then to implement becomes a problem. So download it, set up your own system as I do it from here. So you can pause the video, try your own. If you see a number, change it. If you see something, just experiment, and that way you can actually get to learn. All right, so till I come your way again, keep doing data right. Bye.